Howdy, my name is Kristen Koike and I am a junior in mechanical engineering. This past school year, as mechanical sub-team lead, I contributed to the hull design by teaching new members the fundamentals of materials and fabrication, which were used to delegate the component design. This summer, I contributed as the team co-lead by coordinating the implementation of the upgraded processor and camera between the mechanical, electrical, and programming sub-teams to decrease volume displacement.
Hi, my name is Jessica Ganley, and I am a junior in mechanical engineering. This year, I was a co-lead for the WE AUV team.
Howdy, I'm Caitlin Lancaster. I'm a freshman aerospace engineering major, and this last year I was working on the mechanical sub-team, specifically on the end cap, acrylic insert, and pressure collar design for this year's submarine.
Howdy, we are supported by the Women in Engineering program at Texas A&M University. Our team is made up of 40 female Aggie engineers. This year will be our 6th time competing at the RoboSub competition. We have members of all experience levels and engineering majors in order to ensure that we reach as many students as possible. Our hull is a polycarbonate cylinder with an aluminum midcap in the center and aluminum caps on either end. This year, we modified our end cap design to accommodate our new Z Mini cameras. Because the new camera is not water resistant, it will be housed in the hull. The front end cap now has a rectangular hull. This will be sealed with an acrylic piece, creating a window for our camera. The acrylic piece will be attached with a gasket on the outer rim. It will then be held in place using an aluminum pressure collar bolted to the end cap. And of course, we still have our designs engraved on the front end cap to keep our team's personalization, even with the reduced surface area. We reused the midcap from our previous vehicle, Nessie, and modified it to fit our new needs while conserving resources. It connects the 2 polycarbonate tubes and is mounted to the top of the vehicle's frame. The tubes are attached using a bore seal and 4 latches per connection. This ensures that the hull remains watertight while giving us the ability to detach both ends when desired. By making these tubes removable, we are able to access the internal components efficiently. This is not only effective for testing and troubleshooting, but makes it easier for our team to teach new members about our system, allowing for a greater knowledge transfer. On top of the midcap is a hole for our subcon tether. On both sides, there are detachable midcap panels. The internal frame provides the structure for the storage of all our internal components in a limited space. In order to accommodate for the heat of the electrical component, we plan to 3D print the frame with PEEK filament, which has a heat resistance of up to 480 degrees Fahrenheit. The internal frame was completely redesigned this year in order to fit our Jetson TX2 as well as new components and electrical systems. Our competition strategy in regards to the hull design is mostly focused on qualification and ensuring that our vehicle remains submerged throughout the entirety of the course. The sizing of our hull in relation to the weight of our vehicle allows us to create a positive buoyancy while remaining as close to neutral as possible. This puts less stress on the thrusters to keep the vehicle submerged, allowing for increased mobility. With these improvements to our hull, we are confident that our vehicle is capable of passing through the gate to qualify. Our hull also greatly contributes to the balance of our vehicle. Even with the reduced size, we are able to ensure that the weight of our vehicle is evenly distributed. Following qualification, we will be able to more efficiently take on competition tasks with the new systems housed in our hull, such as our camera. We will be able to locate and accomplish the tasks much more efficiently. We took a top-down approach to our designs this year. We began by determining all components that were necessary and designed around them. For the hull, we began with electrical. First, all components were blocked out in the most effective way that allowed for proper power distribution and provided the needed connection. From there, we built our internal frame around these blocks to fit within our midcap. The design of our hull was based on our successes and challenges of our previous 5 years of competing. While many changes were made, the general shape and pieces of our hull have remained the same. This is the first year that we have reused parts from previous vehicles. By adding detachable panels to the sides of the midcap, we will be able to continue using this midcap for longer. As our needs for the vehicle evolve, we will be able to just redesign the panel, not replace the entire midcap. Also, we found that by placing the subcon attachment on the top of the midcap versus its original location on the side, we were able to decrease drag during testing and allow for more accurate navigation. When possible, testing was conducted in the fountains of our campus. When we were unable to do so, we created prototypes out of household supplies so that students could test on their own. Thank you to our sponsors, the Texas A&M Women in Engineering program, the Fisher Engineering Design Center, L3 Harris, Qualcomm, Accenture, and Blue Origin, who help make what we do possible. Though these past 2 competitions have been different, we are so grateful for the opportunity to show off our accomplishments and compete in this year's RoboSub competition. Thanks, and gig 'em.